Example 4. Show that 1.0031543 with the 543 repeating as a rational number. So, once again, write nothing. Line below that, write x equals, a little bit of space, 1.0031543 with the 543 repeating, and put a 1 in front of the x. Always start off there with a repeating decimal when you're trying to convert it to a fraction. X equals the number. Again, leaving some space here, it just allows you to have not such a cramped in look on your paper when things happen. So, this time 3 digits repeat, so we're going to do 10 to the 3rd power, which is 1,000. So times 1,000x, and times 1,000 puts it right here, so we get 1,003. And then we're going to get 1, right? There's the 1. And then 543, and then 543.
How did we get 1,003 on that side?
3 digits repeat.
Yeah.
How did I get 1,003?
Yeah.
With the decimal point
Oh,
there.
I see. Okay, no.
All right. The other one didn't have a number in front, it was just 0 point whatever, so it just there were a bunch of zeros in front. This time there's a 1 in front, so I can't just make it go away.
Yeah.
All right? And that's the reason why you want to leave this space here, because that happens enough that you want to allow yourself space there. You want things to line up nicely. You want these 543s. But again, 543 repeating could start here, but again, we want to put one of them down, put a second one down so the repeating parts line up. Put a bar there. We're going to subtract the blue from the red. For the sake of your paper that doesn't have blue and red, subtract the bottom from the top. Okay. 1,000x minus 1x makes 999x. The 543 repeatings are in the same locations. Look, decimal place 1, 2, 3, 4, 5, 5, 4, 4, 3, 3. They all line up, right? 5th, 6th, and 7th places. So all the way down to infinity, these go away. So that's the whole idea here, that we want the infinities to go away, lining up. If you don't multiply by the right power of 10, they don't line up and they won't go away. As far as this is concerned, 3 minus 1 is 2, 4 minus 3 is 1, 5 minus 0 is 5, 1 minus 0 is 1, 3 minus 1 is 2, and they get 1,000. 1,002.1512 over 999. So x equals this. Again, this is not a good fraction because we got a decimal on top. So I'm going to put 4 decimal places on the bottom. Top, I'm going to put 4 on the bottom. So if I drop the decimals off, I end up with 1,002.1512, better known as 10,021,512. On the bottom I have 999,000, which is better known as 9,990,000. And again, reduced to lowest terms. Okay, let me just say this. The back of the book does not reduce to lowest terms. The back of the book is lazy. We don't want to be the back of the book. All right, I want everything reduced to lowest terms. The answers on my answer key are reduced to lowest terms. So if you have this answer and mine is reduced to lowest terms, you're going to lose a point on homework. You can lose half a point or half credit on a test. All right, always reduce to lowest terms. Again, all you have to do is focus on the denominator. All right, 999 is 9 times 111. 9 is 3 times 3. 111 is 3 times 37. And then we got 2, 2, 2, 2. And we got 5, 5, 5, 5. All right, first thing I like to do is get rid of the ones that don't work. All right? You ever see 5 doesn't go into it? No. So let's throw the 5s out. There's a divisibility rule for 7. Much easier to just type in your calculator. If you want to see the divisibility rule for 7, I'll show you later. But
37 or
for 7. There's not one for 30. As far as I know, there's not one for 37. I'm going to say there isn't one. I don't know it. Divided by 7. This is the easiest divisibility rule for 7. Just type in your calculator. It comes out decimal. It doesn't work. It's decimal, so it doesn't work. So throw out 7. We don't have 7. Why am I doing 7? I'm sorry. There's not a divisibility rule for 37. So 1002, 1512 divided by 37. Doesn't work. All right, so throw out 37.
It don't work anyway.
There's a rule for 3, but it's probably easy enough just typing in 1002, 1512 divided by 3, and it comes out, oh, that comes out, so 3 works. All right, so what I'm going to do is I'm going to circle the ones that work. So 3 works. All right. I'm going to try dividing by 3 again, and it doesn't work. So we'll start with the 3340504. All right. So 3 worked. Keep that in mind. All right. Will 2 go into that?
Yes.
It's even, right? So divided by 2,
That works.
2 works. So we'll circle a 2. All right. That's still even, so we'll divide by 2 again. So 2 works again. Circle it. Still even, so I divide by 2 again. Circle it. Now it's odd, right? So 3 didn't work anymore. Now it's odd, so 2 doesn't work anymore. So this is everything that divided the bottom. 3, 2, I'm sorry, the top. 3, 2, 2, and 2, right? Which is a total of 24. Right. So the top is going to reduce to 417,563. The bottom, if I just type the bottom in, 999,0000. There you go. Divided by 24. That's what we divided the top by, right? And that gets me 416,250. That's how you reduce the lowest terms. Find the primes that go into the bottom, see if they go into the top, keep track of the ones that went into the top, make sure you divide the bottom by the same number. And again, very easily checked. This number here that we got circled is supposed to equal 1.0031543 with the 543 repeating. If I type in my calculator, 417,563 divided by 416,250, it equals 1.003154354. And we can go ahead and assume the next number is going to be 3. So it's a repeating part there. So it makes the right answer. Again, I expect lowest terms. I think everybody has the ability to do that basic arithmetic to get the lowest terms. So do that every time. Don't be lazy like the back of the book.